Comics, please deliver. Oh, hey guys, what's going on? Memes here. So, apparently, while cruising on this internet stuff and things recently, I started looking into some sciencey things and some maths. And one of the things that I noticed, I'm like, wait a second, what's this? The CMB? The cosmic microwave background? Look at it. It's beautiful. Almost kind of looks Earth-like if you were to rearrange it with some different colors. And the cosmic microwave background, or CMB, fills the entire universe and is leftover radiation from the Big Bang. This is brought to us by the European Space Agency there. But the interesting thing that I found is, where do they get to it? So they were estimating it around 3 degrees Kelvin, about 2.73 degrees Kelvin. And then more recently, it's been measured at an average of about 2.726 Kelvin. Well, that's amazing, isn't it? Now, the interesting thing was, I also found this. What's this? Oh, this is Euler's number, brought to us by Math World. With a possible exception of pi, E is the most important constant in mathematics since it appears in a myriad of mathematical contexts involving limits and derivatives. The numerical value of E is 2.718. CMB, 2.726. And apparently falling because the universe is expanding, so it's kind of cooling off. Wait a second. Could it be possible that the cosmic microwave background is closing in on Euler's number? I don't know. All I know is you've been warned.
Though I know I should be wary, still I venture someplace scary. Ghostly haunting, I turn loose. Beetlejuice! Beetlejuice! Beetlejuice!
Welcome now, everybody. Thank you so much for joining us. Yes, I see you there, Parrothead. Don't worry. There's going to be plenty of music and squirrels in the future, as well as LDG working on Project Prometheus. We do need to catch up again and go over some of the stuff. And you know what, DJC? It's all right. I am bad at the math. I am so bad at I literally didn't understand math like halfway through the 6th grade, where our teacher was like, now you don't need to know this now, but this will be useful later. So I was just doodling in my notebook. And that was the day they taught us how to cross multiply fractions. And then once I got to 7th grade, and they're like, hey, so now that you know how to cross multiply fractions, here are some letters. And I was thrown off, and I swear the system probably just moved me forward and stuff. Or my teachers like me. But anyways, that's not what we're here to talk about today. What we're here to talk about is basically the universe in and of itself. Basically the cosmic microwave background radiation. Yes, it's this beautiful thing that we have right around here. Yes, and basically what this is essentially based upon the Big Bang, that particular theory that seems to be the most prevalent one, as well as an excellent show that I've watched plenty of episodes of. But essentially, yeah, the big boom, and then once everything kind of started to settle, you started to get these photons, and basically these are the OG photons of the universe, the original light as old as we can see. And this is based upon a number of different measurements. And slowly over time, it was estimated about 3 degrees Kelvin. And some folks were saying it was 5 degrees Kelvin. And as our instruments have gotten better and better, we've basically closed in on basically 2.726 Kelvin, approximately negative 270 degrees Celsius. So basically, it's a little under 3 degrees above absolute zero, essentially the physical limit of, yeah, there ain't no more motion here because there ain't no temperature and ain't nothing oscillating here. But I found it interesting because I've been doing a little research into like basically math and how potentially the fabric of the universe might come up with. That brought me to E. And basically this is that math thing that's used to predict a number of different patterns as well. It's named after I believe it was a Mr. Euler there. And if you notice that, it's like, all right, when we go into Wolfram Alpha, and we plug in E, and we divide it by 2.725. Again, that was another thing that I got. We're off just a little bit there. I apologize for my inaccuracy, but that comes down to about 99.7% match. Now, again, when you're dealing in such large scales, that's a freaking huge difference. You're not quite there yet. Yes, it might be within a couple of hundredths there, but those hundredths matter. Now, Could that potentially be dust? Could this potentially just be a natural equilibrium of the universe in and of itself? I have no idea. But what I found interesting was apparently when I plugged this in, I happened to get some of these characteristics, and I noticed this, and I'm like, wait a second. And again, this is 0.366. And I saw that number, and it looked familiar. Now, all I know is if we pop in and you see they start talking about, I think, Snell's laws or something over here. But basically, if you take that particular number, which is the CMB, that basically, if n equals that, number one, you get to about 15 degrees, or 45 degrees, which if you're going to encompass a whole 360-degree plane, that's 8. So I'm not saying that it necessarily has anything to do with this, but it might have a little to do with this. I don't know this. Again, this is pure speculation here, but that 3.66 thing, I was interested. So what I did was we used the Googles a little bit, and I found this paper. And this is basically from Astronomy and Astrophysics. This is a manuscript, basically about the unexpected topology of the temperature of the cosmic microwave background. This was published in 2018. And what I found was interesting is when we actually start to search the paper, what we find in here is, as we can see, there are reports of mildly unusual behavior of the Euler characteristic at 3.66 degrees in the literature, computed from independent measurements of the CMB. So if we pop a little ahead here, and we go down here, as we can see, results based on smooth maps, corroborated with those based on degraded maps in terms of approximate scales at which the anomaly is observed. We also compute the absolute homology for the dataset and confirm that the results are consistent with those from a relative homology. External evidence that these derivations are not a result of overanalyzing the data comes from the fact that the variance of the observed CMB is anomalous with respect to the standard model at n equals 16. The Planck collaboration et al. 2014b. And the computed power spectrum exhibits a dip roughly at this range of scales. In addition, there are reports of a mildly significant Euler characteristic at 3.66 degrees, n equals 16, Erickson et al., 2004, computed from independent measurements of the CMB. Now, all I'm saying is I just find it interesting when you plug in certain things and you see different, and I realize the combinatorics, it's just a number there and it's point this, and again, I am looking for this and I am completely biased as well. I think we should be honest about that, but if there happens to be a connection, and there happen to be plenty of smarter folks out there than me, especially about this stuff out there, if maybe this was a different perspective that maybe we hadn't looked into before, because if we finish on, computed from Planck's predecessor. Yes, computed from independent measurements of the CMB by Planck's predecessor, Wilkinson microwave anisotropy probe, the WMAP satellite. This can be explained by a significantly high number of loops and components together with cancellation effects that the Euler characteristic suffers from. By definition, similar observations by independent satellites make it unlikely that the source of the anomaly has its origin in instrument noise or systemic effects. Basically, it kind of sounds like they're saying it again. I am not an astrologer. That is Professor Keating. Now, with this, it sounds like we don't think this is wrong. We think there might be something here. That's what I'm kind of taking away as a very poor science communicator. But moreover, the medium superhorizon scales at which we observe it could possibly point to a cosmological origin. The non-parametric Turkey depth test shows observations to be different from the simulations at almost all resolutions, regardless of the preferred test. Evidently, the topological structure of the CMB is deviant from the simulations, at least on some scale. Now, again, I'm not saying that this necessarily has anything to do with it. And again, I'm actually just putting this out there because I want to do a more detailed video on this. And as I kept digging more and more and more, Gets more and more interesting. There's more and more stuff I need to learn about this stuff. But welcome Monterey. Welcome Monterey. Hey, why thank you. It's much appreciated, my friend. And yes, 2.7, excuse me, 2.725 or 6, give or take a couple of 100,000ths or something of a degree Kelvin. Yeah, that's freaking cold. It's like, yeah, that's instantly, you don't want to get spaced at that. That's a bad thing. As well as welcome Luciferian. And yes, hey, gaming, you know what? People that wear shirts, they're people too. I just happen to believe in shirtless equality. That's all I'm saying right there. Yes, I am totally a ridiculous lunatic. Welcome, everybody. But all I'm saying is, and again, I didn't want to release anything that hadn't been released. I wanted to make sure it was actually in one of Thad's other videos. 3.66 happens to be part of the partitioning function for the hyperbolic vortex equation. Again, according to Thad Roberts, I'll try to remember to relink it back there, but I did have a conversation with him, and I'm thinking we're getting really close. Like, in my mind, again, maybe this will be the first time I actually put this out there publicly, but I think we might actually have some form of a corpuscular Lagrangian oscillatory cyclic kinesis strings. So you could potentially say that the general lattice, again, this is just an out there proposition. Again, this would all need to be modeled. This would all need to be confirmed by experiment and everything like that. But if you get something kind of like the hyperbolic figure 8 knot on its complement, that's making up basically the lattice of space-time itself. It kind of sounds like some of the OG string theorists may have actually been right before we kind of started to deviate into, oh my God, we're just going to slap string theory on anything potentially because that gets funding because people are excited about it. And again, I apologize to anybody in the industry. We wouldn't have been able to get here without all of this work and everything. So it's like you give credit where it's due. But if you did happen to have a fiber bundle in the simplest balanced manifold, all of the hyperbolic figure 8 knot its complement, and that's literally weaving space and time itself, all I'm saying is if you start to notice something within a particular degree range, and there may potentially be an association with our partition, basically that's a boundary of the physical fabric of reality itself. If that happens to be the case, I don't know. All I know is maybe we can make 5D printers, a la replicators, and if not, we've got to be able to make some dang good video games from all this tech. So that's all I'm really saying here. But hey, it's good to see you all. Swing by once in a while. Maybe hit me up on Discord or the Twitters. This is the thing. We go through all different icon states. It's being broadcast to YouTube, to Facebook. There's so much to learn. There's so much to keep track of. I haven't been on Discord for like a week, and it's like, oh my God, it's kind of nice to get away from drama and everything. But it's like, I do miss people, and I like people because human beings, well, we're here. We do our thing. Why? Because we can. But just want to get a little sciencey stuff out here, and we'll look into it. And apparently, some of the folks, especially in our comments, because totally comment, because this is how I find a lot of these people. It's like somebody mentions something, you find a connection here. There's another guy by the name of Mr. Ken Griggs. I think he actually studied under Professor Jim Gates. Professor Keating and Professor Wolfram had him before. Basically, I think he's one of the fathers of supersymmetry. And apparently he said that they may have found ways to overcome gravity in at least silica. And again, I need to look more into this, but all I'm saying is the future may be here sooner than we actually think. But no matter what happens, just remember. What rolls downstairs over and bears rolls over your neighbor's dog. What's great for a snack and fits on your back and slog, log, log. Thank you all for watching. Peace out, everybody. Be safe. And again, no matter what happens.
I put the fires out.
That was the wrong clip. See you, everybody. Be safe.
How do you know if any of this stuff is true? How do you know someone didn't just make it up?
What? You mean just lie? You really think someone would do that? Just go on the internet and tell lies?
I just mean that some of the details...
No, I never thought of that. This is terrible. What if none of it's true? What if they're all lying? How would we ever know?
Have you guys checked out the Memes of Destruction's channel? He's an interesting dude. I like him.